Experiment number 4, determination of partition coefficient of an iodine between carbon tetrachloride and distilled water. Aim of this experiment is to determine the partition coefficient of an iodine between carbon tetrachloride and distilled water. In requirements, chemicals like distilled water, iodine crystals, carbon tetrachloride, zero point 0.1 normal sodium thiosulfate, zero point 0.01 normal sodium thiosulfate, starch indicator. Apparatus like separating funnels, reagent bottles, beakers, burettes, pipettes, conical flask. Theory behind this experiment is when an excess amount of slightly soluble solute, that is solid or liquid, is added to a mixture of two immiscible aqueous and organic liquid phases, it distributes itself between two phases until saturation takes place. It is mixed by shaking vigorously. If insufficient amount of solute is added, it distributes itself between two phases in a definite ratio up to the saturation. This phenomenon is called as distribution law or partition law. Conditions essential for partition coefficient are temperature and pressure affect solubility and hence should be maintained constant. Solubility of solute should be good in given solvent. It should follow equation of partition coefficient for ideally dilute solutions and it does not hold for higher concentration. The concentration of the solute are noted after the equilibrium has been established. Mutual solubility of solute should be same in both phases even on addition of any amount of the solute. If two solvents are immiscible, only slightly soluble in each other, the mutual solubility of both the solvents must remain unaltered by addition of solute to them. This law is applicable for only solutes which are soluble in both phases and undergo no chemical changes like association, dissociation, hydrolysis, complex formation, salt formation, or degradation. Applications. It is useful in determination of type of delivery system for newly developed drugs, in the preservation of oil-water system like emulsions, the drug action at non-specific sites in that the distribution of drugs in the various body fluids is governed by their distribution coefficient between the blood and various body fluids. Partition coefficient is measure of drugs hydrophobicity and an indication of its ability to cross cell membranes. Hydrophobicity is related to absorption, bioavailability, hydrophobic drug receptor interaction, metabolism, and toxicity in the body. It helps in determining molecular formula and stability constant of a complex. In the determination of solubility of solutes, in study of chemical equilibrium leading to the formation of complex ions, in partition chromatography. About procedure, prepare approximately 110 ml of saturated solution of iodine in carbon tetrachloride and use it as stock solution. Prepare mixtures in 4 separate bottles and label them as A, B, C and D. A bottle will contain 50 ml distilled water, 40 ml stock solution and 10 ml carbon tetrachloride. B bottle will contain 50 ml distilled water, 30 ml stock solution and 20 ml carbon tetrachloride. C bottle will contain 50 ml distilled water, 20 ml stock solution and 30 ml carbon tetrachloride. D bottle will contain 50 ml distilled water, 10 ml stock solution and 40 ml carbon tetrachloride. Place stopper on each bottle and shake the content for 30 minutes. Note that result variation depends on the shaking, hence more and effective shaking is essential for reproducible result. Transfer these mixtures in separating funnels labeled as A, B, C and D and allow to stand for 10 minutes to separate the layers. Close top end of pipette and insert its lower tip in the lower organic layer through upper aqueous layer to withdraw 10 ml of sample and transfer to iodometric flask. Add about 10 ml of 10% weight by volume solution of potassium iodide. Note that do not withdraw organic layer from the separating funnel by opening the stopcock because evaporation of organic solvent and sublimation of iodine may change the concentration of iodine in organic layer. Titrate 10 ml organic layer against 0.1 normal sodium thiosulfate using 2 to 3 drops of starch as an indicator. Endpoint, pink color to color of organic layer disappears. Pipette out 10 ml of upper aqueous layer separately using a dry pipette and titrate against 0.01 normal sodium thiosulfate as starch and indicator. Endpoint, blue color disappears. Repeat step 6 and 7 for all remaining samples. During this procedure, you have to make observations like V organic, that is volume in ml of 0.1 normal sodium thiosulfate per 100 ml of organic layer. V aqueous, that is volume in ml of 0.01 normal sodium thiosulfate per 100 ml of aqueous layer. N organic, that is normality of organic layer. N aqueous, that is normality of aqueous layer. C organic, that is concentration of organic layer in gram mole per liter. C aqueous, that is concentration of aqueous layer in gram mole per liter. Calculate partition coefficient by the formula C organic upon C aqueous. K is partition coefficient of iodine in water and carbon tetrachloride. Also, calculate log C aqueous and C organic. About calculation, for aqueous layer, concentration of iodine in aqueous layer, that is N aqueous of a bottle A, can be calculated by N1V1 is equal to N2V2. Therefore, N1 is equal to 0.01 multiplied by V2 upon 10. Concentration of iodine in aqueous layer, that is C aqueous in moles per liter, can be calculated by formula 0.01 multiplied by V2 multiplied by 126.90 upon 10. That you will get in moles per liter. Similarly, calculate concentration of iodine in aqueous layers of other bottles B, C and D. For organic layer, concentration of iodine in organic layer, that is N organic of bottle A, calculated by formula N1V1 is equal to N2V2. Therefore, N1 is equal to 0.1 multiplied by V2 upon 10. Concentration of iodine in organic layer, that is C organic in moles per liter, can be calculated by formula 0.1 multiplied by V2 into 126.90 upon 10, that you will get in moles per liter. Similarly, calculate concentration of iodine in organic layers of other bottles B, C, and D. Plot graph C aqueous on y-axis versus log C organic on x-axis. By these calculations and plot, you can write result in such way that the partition coefficient of iodine in distilled water and carbon tetrachloride by calculation is and by graph is. Since n is equal to 1, iodine has its normal molecular weight in both the solvents. Note, the value of n should be in between 0.5 to 1.5. Thank you.